Are we good?
We're good.
Okay. Hello, my name is Jess Kaminsky, and I am a second-year master's student in the Biostatistics department here at Brown. And today I'm here to talk to you about longitudinal study design and also ecological and cross-sectional studies. Okay, so before we get started into the study designs, I'm going to review some key terms with you. These are just going to be important definitions that I want you to know before we get into the details. And then I'm going to talk about, as I said, longitudinal, cross-sectional, and ecological studies. Within each of those, I'm going to present some advantages and disadvantages of conducting these study designs. I'm going to talk about how you analyze these. I'm going to talk about sources of bias that might present themselves throughout these studies. And then I'm going to present one or multiple case studies so you can see an applied example of these designs. So the first term that I want to go over is bias. Bias is defined as any systematic error in the design, conduct, or analysis of a study that results in a mistaken estimate of an exposure's effect on the risk of disease. So bias comes in two sort of flavors. One is information biased, and this comes from incorrect data collection or data analysis. And then you can also have selection bias, which comes from incorrect participant selection. So this looks like maybe your sample population that you're studying doesn't quite look like the population that you want to generalize your results to. The second key term I want you to know is prevalence. This is defined as the number of affected persons present in a population at a specific time divided by the number of persons in the population at the time. So you can think of this as the proportion of individuals within a population that are affected by a disease at a specific point in time. You can also think about this as a number that's constantly changing, because today the number of individuals with a certain disease might be different than the number of individuals with a certain disease tomorrow. Also, the size of the population that's at risk will change. People are born, people die, things like that. The last term that I want you to know is incidence. This is defined as the number of new cases of a disease that occur during a specified period of time in a population at risk for developing the disease. So instead of just looking at one point in time who does or does not have the disease, we're looking at over some specified period of time how many people have developed this disease. So we can think of this as more of a measure of events that are happening and risk of developing a disease. And similarly to prevalence, this is the number of new diagnoses in that time period divided by the number at risk of a new diagnosis during that time period. So now getting into longitudinal studies. Longitudinal studies are studies that happen over a long period of time, and you're following a group of subjects over time. The unique thing about this study design compared to other study designs is that you're following the subjects over time, and you're getting multiple measurements of those subjects over time. So say you are studying something about weight. So you're collecting your subjects' weights maybe once a month for an entire year. Whereas in other study designs, you might just collect the weight measurement once. What's unique about this is this allows you to collect both between and within subject differences. So what that means is a between subject difference is something that you can calculate in most studies. It's just a comparison between one subject and the other. A within subject difference is a difference that is, you're comparing a subject to themselves. So if you had all 12 of my weights from every month this year, you could compare myself to myself and see how I changed over time, which is not something that you can necessarily do with a study where you only have one observation per person. Now, because this is something that happens over a long period of time, before you start your study, you need to make sure that you have adequate resources and you've designed your study in a robust way so that you can carry it out for as long as you need in order to answer your research question. And with that, the more time that you invest in your study will improve the accuracy of the data that you receive and the validity of your results. Now, typically, longitudinal research is observational, meaning that we select our sample population and we just watch them and follow them over time. However, it may be experimental. So like I said, if we were conducting a weight study, maybe it's a weight loss study. And if it's an experimental study, what we're doing is we're imposing a treatment on one or multiple different groups. So we would be comparing them. We would have a placebo and then maybe a weight loss drug or an exercise regimen or something like that. I wanted to show you this map of sort of to visualize what a longitudinal study looks like. You start with your entire population, and then through some sort of inclusion and exclusion criteria that is defined based on your research question, you refine to a sample population, and you have the subjects that you're going to then study and follow throughout your study. And then you're going to follow up with them any number of times. And that again is going to be based on your research question and some predetermined number of observations you want, and also how frequent or infrequent you want to observe your subjects over the duration of your study. Now, I briefly wanted to mention the difference between longitudinal and prospective cohort studies, because I presented prospective cohort studies in the first sort of intro to study design seminar. Now, a prospective cohort study is a type of longitudinal study. You are following subjects over a long period of time into the future. However, the difference is a cohort study is you start with a cohort of people who typically share a pre-specified set of risk factors. Whereas with a longitudinal study, you don't necessarily need to have a cohort of people who have the set of risk factors. Now, when you're conducting a longitudinal study, there are some more considerations that you need to think about before starting compared to other short, quick studies. You need to make sure you have the infrastructure and the funds to withstand the duration of this study. You want to make sure that you have procedures set up such that your data collection is consistent, and that the way that you're measuring and recording your data is not open to interpretation. So for example, if we're looking at weight in some longitudinal study, it's going to be much better if you are recording your subject's actual weight from a scale, say in pounds. You want to do that consistently with all of your subjects. And that's going to be much better than instead of just measuring their weight, say for some reason you wanted to have an interviewer record subjects' weights. But instead of actually recording weights, you just decided that your variable was going to be the level of how over or underweight they are. So it's underweight, appropriate weight, overweight, or obese. So if you do that, this might be subject to the interviewer's opinion. And so you want to avoid that as much as possible, because this is going to bias your results. And for example, if you had multiple interviewers, you might get different results, and it's not going to be consistent. You also want to make sure that your subjects are relatively geographically stable for the duration of your study, so you're not at risk for losing a lot of your participants and therefore losing a lot of your data. However, it is possible that some subjects might move and not be able to participate in your study. You want to try to mitigate that by maybe creating some sort of phone survey so that you can still receive that same information and minimize the amount of data that you're losing. So engagement and commitment of organizations contributing to the project is essential. This is a way of allocating funds prior to the start of the study to ensure that you have the infrastructure you need to therefore withstand the duration of this study. In that map, I showed you following up 1, 2, 3, up to n times. So the frequency and the degree at which you're sampling should vary according to your primary goal. So do you care more about how much my weight or individual's weight changes over time from month to month? Or do you care more just about how much it changes from the beginning to the end of the year? That will give you some sort of insight into how often and how many follow-up visits you should have. You also want to make sure you have consent and that your study is as ethical as possible to maximize your participant retention. This is, again, going to ensure that you have as much data as possible at the end of your study and subjects have not dropped out. However, if you do find that subjects are dropping out, it would be great to conduct exit interviews to offer insight into these uncontrolled departures and figure out how you can mitigate that in the future. So when you're beginning your analysis of longitudinal data, at the end of your study, you've collected all your data, you have repeated measures for each subject throughout the study, and your goal is to assess changes in outcome over time. Maybe it's fully from beginning to end, or maybe it's month-to-month changes. You also want to examine the effect of other measured variables on the change in outcome. So if it's experimental, maybe how does treatment status affect the changes in outcome, or how is it different between those two groups? Now, when you're conducting statistical testing of longitudinal data, you have to consider some things that you might not necessarily consider in other studies. First is the linked nature of the data for an individual. So this is just the fact that over 12 months, my weight measurements are just inherently going to be more similar to each other than any other individual's weights. Second is the coexistence of fixed and dynamic variables. So what this means is you're collecting data over time at multiple time points, but some of these measurements aren't going to change. So if it's experimental, your treatment group probably isn't going to change. Your sex is not going to change. However, your weight will probably change. So the fact that you have two separate types of variables in your analysis needs to be a consideration. There's also a potential for difference in the time interval between your observations. So if we're measuring weight and it's just our weight is being measured at a visit once a month, it's possible that I had my visit on January 1st, and then I had my second visit on February 28th. But some other subject might have every single visit on the 15th of the month. So their observations are very consistently spaced. So you need to account for the fact that all observations are not, they don't have the same time intervals in between them. And then the likely presence of missing data. So because this is a long study, it's likely that subjects might drop out, or because it's a long study and, for example, it might be visit-based, a subject might miss one or two visits, and you have to consider that in your final analysis. I touched on this before. In cross-sectional studies, which we'll get to later, you can only estimate between subject differences. You can only compare someone to the others because you only know one thing about the person. However, in longitudinal studies, you know multiple things about a person, so you can compare them to themselves. It's a within subject change. We want to model the correlation between repeated measures and the relationship between the predictors and outcomes. So I'm going to show you visually kind of how we do that. But again, this relates to the fact that data from a specific individual is going to be more similar to each other than data from another individual. So some visualizations with longitudinal data. This first one is, so we have each line is a subject, and each different graph is a different treatment group. Subjects are receiving treatment, drug A, B, or C. And what you can see is that each individual has a very different trajectory. Some of the lines are going up, some of the lines are going down, some of the lines start high, some of the lines start low. And so you miss out on these trends if you aggregate your data. And this is a benefit, an advantage of a longitudinal study design, is that we can tease out these trends and look at individuals and see how they might differ. I wanted to show you what missing data, in this case, this is loss to follow-up, and this could result in loss to follow-up bias, which we'll go into later. But if you see here, let me highlight, right here, this point just sort of drops out. And the subject just dropped out of the study. So we don't have any more data on them. And we see that here, and we see that here, We see that here. And this is going to bias our results because we don't know what happened to these subjects, and we're just missing that information. And longitudinal studies are very subject to this kind of data loss. I just wanted to show you this one so you can see what exploring data over time looks like. So this first graph is the distribution of, we're looking at bone mineral density in young girls over time, and so that's supposed to increase. So we do see this increasing trend. However, we're aggregating all of the data together, so it's sort of condensed towards the middle. However, when we look at this one, we see that this one on the left is the calcium group. So these girls were receiving calcium supplements. And this one on the right, these girls were receiving a placebo or nothing. And you actually do get to see that these girls, in the end, their trajectory is faster, and they end up with a higher bone mineral density in the end. So when you aggregate, sometimes you may miss out on trends that arise when sorting out data by groups, in this case, but also it's the same for individuals. Finally, the last visualization I want to show you is the correlation among your measurements. So these positive, strong, linear trends show us that these measurements, so the first bone mineral density measurement and the second bone mineral density measurement, are very correlated, which is a visual representation of what I was telling you about how my bone mineral density measurements are going to be much similar than someone else's, inherently because they're mine. So common errors in statistical analysis: underutilization of the available data if you aggregate it. You can underestimate the variability if you fail to consider the fact that you have both within and between subject variation. There's differences between individuals, but there's also differences within an individual themselves. So different sources of bias within a longitudinal study. So I told you that there's selection bias and there's information bias. In a longitudinal study, we can see three common types of selection bias. The first two, lost to follow-up bias or non-response bias. So these are both missing data problems. Our subjects either drop out or they miss observations. Or non-response bias is maybe if our data is collected via a survey, our subjects just fail to respond. Membership bias looks like if our whole sample population shares a common characteristic or is in the same type of group, we fail to be able to generalize to individuals outside of that group at the end of our analysis. Information bias, this will result in misclassification of an individual. In this case, we can have interviewer bias or observer bias. So interviewer bias looks like if you have an interviewer interviewing subjects, like I said, maybe they're asking them questions about their weight or their exercise habits. An interviewer who's collecting data for the study might ask questions in a way that might cause a subject to think that they need to answer in a certain way, and therefore we're not getting accurate results. Observer bias is the tendency to see what you want to see rather than what is actually there. So if the observer knows that you're on a weight loss treatment rather than a placebo, they may be more likely to see or record changes that aren't actually there. So overall, advantages of a longitudinal study design. We have the ability to identify and relate events to particular exposures and to further define these exposures with regard to presence and timing. So this is a very unique and great feature of a longitudinal study, is because we've been studying our subjects and collecting information on them over time, we're able to say what happened first in regards to which exposures came first and which outcomes came first or last. Again, we can follow change over time. We can look at within subject differences. And then we're excluding recall bias by collecting data prospectively. So we're not going to subjects and asking them what happened and giving them the opportunity to misremember. We are just recording that data and we have it. So the prior to knowledge of a possible subsequent event occurring. So if something happens to you, you might remember your symptoms differently and fail to report them accurately. So disadvantages of a longitudinal study. We have incomplete and interrupted follow-up of individuals. This is non-response or loss to follow-up. Attrition with loss to follow-up over time. So our study is losing strength as our sample size decreases and we lose data points as individuals, if individuals drop out of our study. You might inaccurately make conclusions if you fail to account for these statistical things that I had mentioned, for example, the correlation of individual measurements. And then this study particularly is more time and resource intensive than other studies might be. Okay, so I want to give you a case study of a longitudinal study. The Framingham Heart Study, conducted in Framingham, Massachusetts, is considered the quintessential longitudinal study in medical research. So in the mid-20th century, we saw an increase in deaths and diagnoses of cardiovascular disease, but we also saw a decrease in communicable diseases due to sanitation and penicillin. And so there's a drive to identify the risk factors for cardiovascular disease and to really understand the rise in CVD while there was still this decrease in other diseases, which led to the birth of the Framingham Heart Study in 1948. So the Framingham Heart Study had an original cohort of about 5,200 subjects from Framingham, Massachusetts. They were between the ages of 30 and 62, and they were recruited and then followed for 20 years. That was their initial study design. They generated many hypotheses with respect to various risk factors that they thought contributed to heart disease, including age, weight, smoking, blood pressure, cholesterol, and a lack of physical activity. So because this is a longitudinal study, it is certainly subject to bias, as all longitudinal and other studies are. These, in the Framingham's Heart Study, are types of selection bias. It's a failure to have a representative sample population. So the first concern was that our subjects were all living in Framingham, Massachusetts. So the researchers questioned whether or not we could generalize the results to different groups or to people who lived outside of Framingham. Ultimately, they decided that Framingham was sufficiently diverse in both ethnicity and socioeconomic status to mitigate the bias. But their second concern was that the cohorts of subjects that were recruited seemed to be uncharacteristically healthy. However, they considered and acknowledged these biases, but continued with the study. In the end, it was determined to be, from the first cohort, a successful longitudinal study. It contributed to some major findings to medical knowledge that are now considered common today, including, for example, smoking increases your risk of heart disease. This study confirmed many of the hypotheses about the risk factors that I mentioned. And the success of this study was strengthened because the subjects were not using any treatments. It was an observational study or modifiers such as statin therapy or antihypertensives. This enabled the study to delineate the natural history of this disease, and researchers were really to see naturally how this disease progressed. Something interesting that I found just a week ago today, Boston University, who partners with the Framingham Heart Study, just received a $38 million grant to continue this 71-year longitudinal study. So it's really a testament to a good research design, and they had the infrastructure set up to continue this. Their data was well collected and stored, and now they can continue to use this data and continue to collect more data going forward. One little snippet, this might be hard to see, one little snippet from this study, from the article that I just posted, says researchers will examine blood and tissue specimen from about 1,900 participants who joined the study in 1971. These are the original participants' children. While they are all white, the study will include 450 additional subjects recruited in 1995 who include people of color. So I just wanted to point that out, that even today in this article that they're writing about this 71-year-old study, they're still attempting to mitigate bias and make the results more generalizable today. So a brief review of what we talked about longitudinal studies. They may provide a more comprehensive approach to research, allowing an understanding of the degree and direction of change over time. You need to carefully consider cost and time implications before you begin. You want to ensure complete and proven clarity in your design and process before you begin. And you want to consider the peculiarities of your analysis and interpretation stage, so you do not bias your results or come to incorrect conclusions. Okay, so now I'm going to talk about cross-sectional studies, but before I do that, is there any questions? So a cross-sectional study is a study that is strictly observational, and it's also considered a prevalence study because all of the outcomes and analysis that we're doing are going to be with measurements of prevalence. In a cross-sectional study, we want to measure risk factors and outcomes at a single time point. So we get all of our subjects, and then at one moment, we assess their outcome and exposure status, and then that's it. That's all the data that we have for this study. You can think of it as a snapshot at one point in time. Sometimes this is the only feasible option when there's a long latent period between exposure and disease, and it's not really realistic to enroll these subjects and just wait for them to have an outcome. It's also useful when the causes of the outcome aren't known. So this is a map of what a cross-sectional study might look like. You start with your overhead, you would have your full population, and then you would go to this top yellow box for your defined population, which is your sample. And then at one specific moment in time, you gather the same information on each subject, their exposure status and their disease status. And then after that, each subject will fall into one of these four boxes. And your initial data is just a count of who falls into these four boxes. But going forward, we'll talk about what you can do with those numbers. So very simply, when you're conducting a cross-sectional study, you formulate your research question. What do you want to know? What outcome and what exposure do you care about? Then you're going to choose your sample population, and you're going to also collect data on variables that are relevant to your research question. Finally, you're going to devise a method for contacting your subjects and collecting your data. Now, once you've done that, once you've collected your data, your subjects are going to fall into one of these four boxes. We can interpret these four boxes this way. So A is going to be a number, and it's going to be those with the disease who have been exposed. B, C, and D are also going to be numbers. B being exposed and non-diseased, C being unexposed but diseased, and D being both unexposed and undiseased. So I presented this same slide in the intro lecture as well, but I'll just give you a second to sort of look at it and see. This is just a short list of the numbers that we can generate from this table alone. For example, the sum of these four numbers is going to be the total number in our study, our sample size. The total number exposed is going to be the number exposed with disease and the number exposed without the disease, A plus B. And there are also all these other numbers that you can calculate from this table. Okay, but so we have these numbers, but what can we do with them other than just quantifying how many people in our sample happen to be diseased or undiseased or exposed or unexposed? So in a cross-sectional study, it's a prevalence study. We want to determine whether there exists a relationship between our exposure and our disease of interest. We can do that in two different ways. We can look at the prevalence of exposure among those who do or do not have the disease. And we can also look at the prevalence of the disease among those who are or are not exposed. So how many people have the disease among those who have been exposed to it or not exposed to it. So if we wanted to look at the prevalence of those who have the disease in the exposed versus the prevalence of disease in the unexposed, we could do it this way. We could compare these numbers. So A over A plus B is the number of exposed with the disease over the total number exposed. C over C plus D is the number of unexposed with the disease over the total number of unexposed. And we can compare those two numbers. Further, we can compare these numbers by generating a prevalence of disease odds ratio, which is going to quantify the change in prevalence of disease in the exposed relative to the unexposed. So say that I plugged in some numbers here, and in the end, I got the number 5. My prevalence of disease odds ratio is equal to 5. What does that mean? So if I am doing a study where I'm looking at coronary heart disease as my disease outcome of interest, and I'm looking at high cholesterol as my exposure, if I had an odds ratio of 5, I could say that the prevalence of CHD among those with high cholesterol is 5 times higher than those without. Or similarly, CHD is 5 times more common among those with high cholesterol compared to those without high cholesterol. So that's the first sort of statistic that we can look at with a cross-sectional study and these 4 numbers that we have. Similarly, but just sort of the opposite, we can look at the prevalence of the exposed with the disease versus prevalence of exposed without the disease. And this is just going to be calculated a little differently. So A over A plus C, the exposed with the disease over the total number with the disease, compared to the exposed without the disease over the total number without the disease. So then again, we can get an odds ratio by just dividing those two quantities. And this is the prevalence of exposure odds ratio, which quantifies the change in prevalence of exposure in those who have the disease relative to those who do not have the disease. So if you have the disease, how likely are you to be exposed to some exposure compared to people who do not have the disease? So again, if I was doing that CHD and high cholesterol study, and I plugged in my four different numbers here, and I got an answer of 4. My odds ratio is equal to 4. I can interpret this as the odds of having high cholesterol among those who have CHD is 4 times higher than among those without. Or similarly, high cholesterol is 4 times more common, 4 times more likely among those who have CHD compared to those who do not. So we're starting to see some sort of relationship between cholesterol and CHD. If your cholesterol is higher, if you have high cholesterol, it's more likely that you have CHD. Okay, so sources of bias in cross-sectional studies. Again, it falls under 2 categories, selection and information. The new ones here are prevalence incidence bias and recall bias and observer bias. I know we went over observer bias. So prevalence incidence bias is the failure to account for people who have died from this disease. So because prevalence is calculated as the number of individuals with a disease out of the total number of individuals in that population, we're completely disregarding the subjects who might have just died from that disease. We're also disregarding the subjects who are going to have develop that disease tomorrow. And so because we're not including those in our calculation of prevalence, we're sort of missing out on some information, and that might bias our results. Again, non-response bias. If your cross-sectional study design includes a survey to get your information, some subjects just might not respond, and you have less data. The different types of information bias that can be seen here. There's recall bias. So a subject might forget or misaccurately relay their information, and so you don't have the actual truth. Observer bias is an interviewer seeing what they want to see rather than what actually happened. And again, interviewer bias is an interviewer maybe asking leading questions in a way that causes subjects to feel like they're supposed to answer a different way than they might actually do that. So some advantages and disadvantages of a cross-sectional study. It's much less time and resource intensive than a longitudinal study because you just have to collect data at one point, and then once you have it, and then you can analyze it in whichever ways you want to, but there's no follow-up required. This is a good type of study to use when the onset of disease or the incidence of disease is difficult to establish. This can also be used for hypothesis generation. So you don't have a lot of information, but we were starting to see that there's something going on here between CHD and high cholesterol. What do we think is going on? And then we can use that to maybe conduct a longitudinal or other study. Disadvantages, we can't claim any sort of temporal association. We don't know, even though we know which boxes each subject falls into for diseased, unddiseased, exposed, unexposed, we don't know which one happened first. So we can't say that one thing really causes another. Again, the biases issue. This isn't good for rare exposures or outcomes because there's a chance that everyone you sample just doesn't have your exposure or outcome of interest if it's very rare, or you would have to sample so many people that it might not even be worth it. Again, we can't say anything about causation, and we can't really provide a real explanation for our findings. We can just see what's happening. And there might be some confounding. So there might be something else, a third variable going on that's sort of messing with our results. But because we haven't measured it, we've just measured outcome and exposure status, we're not really sure. So the case study here is the BRFS, Behavioral Risk Factor Surveillance System study. So in 1984, the CDC initiated this study, which was a cross-sectional telephone survey that was conducted monthly to landlines and cell phones by the state health departments. They had a standardized questionnaire that they called and asked subjects regarding their risk behaviors and preventative health practices that might affect their health status. The one thing that I wanted to show you from this study, so this is actually the abstract from a paper that was evaluating and trying to quantify the impact of non-response bias in this data set after the study had already been conducted. The 2000s BRFS study had a median response rate of 48%. So this is just people answering the phone and actually participating in the survey. While the 2000 census had a response rate of 67%. So these researchers saw that for some reason people were answering one survey but not the other, and they sort of wanted to understand and understand why and quantify this to see also maybe if they could mitigate this bias in the future and how they might get more responses. So in the end, the results of this was that there were lower response rates were associated with the underrepresentation of racial and ethnic minorities, women and younger individuals in the BRFS study, but not in the census. So I wanted to really present this to you to show that people actually do care about bias, and even after a study has been conducted, people look at bias and write papers just trying to quantify and study the biases that may or may not have been presented in studies that have already finished. So as a quick review, cross-sectional studies are prevalence studies. They're useful for determining and analyzing prevalence. They're quick and inexpensive. You can't determine causation, unfortunately, but with that, you can use them to generate hypotheses that you can carry forward into other studies that you can determine causality with. Are there any questions on cross-sectional studies before I move on? Okay. So the last type of study design today that I'm going to present to you today is an ecological study. an ecological study is a study of group or place characteristics. And what makes this study design unique is that you're analyzing populations or groups. So you're talking about countries or specific groups of people rather than just individuals. Your exposure and your outcome are measured at an aggregated group level. So maybe we're looking at the average weight of a country or of certain groups of people rather than individuals' weights, and we're comparing on a group level. So when you conducted an ecological study, you want to generate your research question. It's the first step of every study. And then you want to obtain your data. Typically, because this is group level data, this might come from a secondary source. So it might come from the census or some other data set, and you're going to use that data set to conduct your analysis. Your exposure and your outcome are typically continuous measures. So when you analyze these studies, I'm gonna show you a handful of visualizations, but typically we look at scatter plots of these continuous variables to observe their relationship. And typically we use simple statistical methods to model these associations. Linear regression is really common. So you see a lot of scatter plots, and then you see maybe a trend line fit between them to make conjectures about associations. So this first one that I wanted to show you is a common ecological study that is presented. So on the x-axis, we have chocolate consumption. And on the y-axis, we have the number of Nobel laureates per 10 million population. And so we see this sort of positive increasing trend. Switzerland consumes the most chocolate, and it also happens to have the most Nobel laureates per capita. China consumes the least and also seems to have the least Nobel laureates. So I think one thing to mention about this is that you should always be careful about inferring causation from trends of correlated data, because I don't necessarily think that this means if we all start consuming chocolate, we're going to become Nobel laureates. But this is what data looks like from an ecological study, right? We don't have individual data points that represent one single person. We have data points that represent countries or groups. So bias in ecological studies. The ecological studies are subject to the ecological fallacy. We have a lack of exposure and outcome data for individuals, right? We just have the average for that group. And so sometimes we fail to account for the variability between individuals within a group. Just because you have an average of something within a group does not mean that everyone is close to that average, right? There's always outliers. Not everyone is the same within a group. So the ecological fallacy occurs when you assume that all group characteristics apply to every member of a group, which we know almost never happens. So to sort of visualize this, we have this graph, which again is showing an increasing trend between daily per capita daily meat consumption and colon cancer incidence per 100,000 women. So we're wondering, we see this graph and we wonder, is meat consumption a causal factor for colon cancer in women? Well, it kind of looks like there's a trend, right? As meat consumption increases, so does the incidence of colon cancer in women. Now let's take New Zealand, that's the highest point right here as an example. It has a high or the highest daily meat consumption and the highest rate of colon cancer. So then my question is, are the individuals who developed colon cancer the ones who consume high quantities of meat? We don't know. It could just be that on average, this country consumes a lot of meat. But there's also a chance that the women who developed colon cancer are all vegetarian. We don't know that, and that's sort of an issue with these kinds of studies. So the answer to both of these questions is not necessarily. We don't know if meat consumption is a causal factor for colon cancer, and the individuals who develop the colon cancer aren't necessarily the ones that are consuming all of this meat on average. Some advantages and disadvantages of these types of studies. They're quick and inexpensive. The data is usually readily available for you. You often don't have to collect it. Sometimes it's the only appropriate design for your research question if you're wondering about an ecological versus an individual intervention. These are really good when your intra-group, your within group variability in exposure is small. So if you're confident that your groups are actually quite similar among most characteristics, then this is a perfectly fine study to conduct. And it's also a great thing to do if you only have group level data. Maybe you only have averages. You don't know what's going on with individuals. You can still do this and plot these graphs and generate linear regressions to get a sense of what's going on. Disadvantages, of course, the ecological fallacy. The secondary data sources is also, it's an advantage, but it's also a disadvantage because you're getting data from someone else that you don't necessarily know how it was generated, and you can't necessarily trust that it's bias free. With that, there's also the potential for confounding. You can't say that there's a time association. Again, you don't know what happened first. Did all these women get colon cancer and then start eating a lot of meat? We don't know. And then finally, sometimes there might be migration across groups. If people move, I think if people move is the best way to describe it. Within states or within countries, then you're sort of mixing your data and you can't say that these are distinct groups anymore. So I wanted to present to you these two plots, which I think show some powerful things that can be drawn from ecological studies and these scatter plots. So in this one on the x-axis across, we just have the number of guns. And then on the y-axis is the number of mass shooters, and it's by country. And so we see this cluster down here, and we see the United States way out here. However, one might say, yes, there's this trend. However, you're not really adjusting for the size of your population, and that could change what the data looks like. And this just makes it look worse than it really is. However, we use that same data, but we adjust per capita. So this is the guns per 100 people. And then this is the mass shooters per 100 million people. And so we do see those bottom points sort of start to fall out a little bit, but we still see the United States out here as the front runner for the number of guns, but Yemen here for as the front runner for the number of mass shooters per capita. So in review, ecological studies, what's unique about them is that your unit of analysis is groups rather than individuals. Your analysis provides overall summary measures rather than individual points or trends. It's useful, again, for generating hypotheses if you want to then conduct a later study based on what you've found. And then these, again, are easy to conduct quickly, and they're affordable, especially compared to longitudinal designs. I have these references for some things. This first one was just one of the definitions at the front, but these are different papers and a textbook that I used in developing these slides. So if you wanted to take a look at those, I think they provide, particularly this first and third paper, provide really good comprehensive information about study design. And that is all I have. Does anyone have any questions? So thank you for attending. There is a course evaluation for those in person. There's a paper one, and then for those online, the survey will be emailed to you. So if you could fill that out, that would be really appreciated. Thank you.